Alright, so today we are going to work on evaluating limits at a point using algebra skills. I will have you know that I've recorded this video 3 times and every time it has failed to upload, so hopefully this time goes a little bit better. Alright, to evaluate limits at a point using algebra, your first method always is going to be substitution. So if I'm looking for the limit as x approaches c of f of x, the first thing I want to try is to plug c into the function and see if I get an answer. If I do, then that's equal to my limit. If I don't, my next attempt should be to simplify with algebra. This might be with factoring or with using a conjugate, which we'll practice again in the video. 2 other ways to evaluate limits are numerically and graphically, which we're going to do. We already did graphically. We're also going to look at the numerically way or the table way in the next video. So, like I said, our first method always is to try substitution. Okay, so you're going to plug in this case we're talking the limit as x goes to a, so plug in a to your function. If when you plug in a, you get a number, or a number over a number in a rational sense, then your limit as x approaches a of f of x is that number, and substitution has worked and all is good. If when you plug in a number, right, and your substitution leaves you with 0, or the form 0 over some number, then your limit is equal to 0. Substitution has worked. Everything is good. If, when you plug in a number, your a value, you get some number over 0, then you've hit an asymptote, and you need to look at the graph. Okay, so you've got to figure out at this asymptote, have I hit it and gone up, or have I hit it and gone down? One of those 2 things will be happening. If you plug in your numbers and you get 0 over 0, then you've hit a hole and you have to keep going. Kind of like Dory, just keep swimming, just keep swimming. You have to keep going and do something with algebra. Okay? So, number is a number. 0 is 0. 0 in the denominator, you've hit an asymptote, you need to look at your graph. 0 in the numerator and the denominator, just keep going. Alright, so, substitution. The limit as x approaches 2, we are going to plug in 2 everywhere I see an x. It's going to be 10 minus 3, which is 7 over 9. Well, that's a number over a number, so my limit is just equal to 7/9. Okay, again, as x approaches 2, my y values are approaching 7/9. -5. Go ahead and try substitution. Ever so carefully with your negative signs. This is going to be 25 minus 30 minus 3 all over 25 minus 5. That results in -8 20ths, which is -2/5. That's a number over a number, so my limit as x approaches -5, my y values are approaching -2/5. Alright, the limit as x goes to 2. Substitution is always your first method. 2 squared plus 3 times 2 minus 10 all over 2 minus 2. Well, in the denominator we definitely get 0. In the numerator we get 4 plus 6 minus 10, which is also 0, which means keep going. So, thinking about algebra, our first method to keep going is going to be to try to factor. So the limit as x approaches 2 of this function up here could be rewritten as x plus 5 x minus 2 all over x minus 2. Notice when you hit a 0 over 0, it means you've hit a hole. That hole will cancel out. So now what I'm evaluating is the limit as x goes to 2 of x plus 5. Because again, I don't care what's going on at 2. Okay, at 2 I know that there's a hole. I care about what's going on near 2. And near 2, my function is going to be approaching 7. So I plug in 2 right here. 2 plus 5 is 7. So if I were to look at a graph, there would be a hole at the point 2, 7. Because approaching from either side, okay, in some capacity, we are approaching the value of 7 as x is approaching 2. Alright, next one, try substitution. We're going to get 5 squared plus 4 times 5 minus 5 all over 5 squared minus 25. Well, in the denominator I definitely get 0. In the numerator I get 25 plus 20, which is 45, minus 5, which is 40. Well, this means that I've hit some sort of an asymptote. And I need to look at my graph. So, if you go to your graphing calculator, go to y equals x squared plus 4x minus 5, all divided by x squared minus 25. I already got that in there. And press graph. You'll notice there is a vertical asymptote at 5, just where we would predict that there would be. So the limit as x goes to 5, well, from this side it's going to negative infinity, and from the right side it's going to positive infinity. And if you remember from limits on a graph, if the limit from the left does not equal the limit from the right, then overall the limit does not exist. So this is going to be it does not exist. Now, if my graph had looked something like this, you could say that the limit was infinity, because both ends are running towards infinity. If my graph had looked something like this, you could say negative infinity, because both ends are going to negative infinity. But because one of ours was going up and one was going down, overall our limit does not exist. Alright, the next example you should have in your packet, I've got to write mine in here. So the limit as x goes to 4 of x minus 4 over x squared plus 10. Well, if I try substitution, and I get 4 minus 4 over 16 plus 10, which is 0 over 26. 0 in the numerator is fine. 0 over 26 is just 0, so my limit is equal to 0. So we've looked at the situation where you get 0 in the numerator, that's just 0. 0 in the denominator, asymptote, got to look at your graph and figure out your limit. And the limit as 0 over 0, got to keep going. Alright, last one, the limit as x goes to negative 3 from the right. Well, from the right doesn't matter, because if we can find that the limit overall at negative 3 exists, then we know it existed from the right and from the left, and they were equal. So first, try substitution. Negative 3 squared minus 4 times negative 3 minus 21. In the numerator, we get 9 plus 12, which is 21, minus 21, which is 0. The denominator, 9 minus 21, negative 12 plus 12, 0. Aha! Keep going. And again, our method to try to keep going is to factor. So what I'm looking for is the limit as x approaches negative 3 from the right. This is going to be x minus 7, x plus 3, over x plus 3, x plus 4. These can cancel. Now when I plug in negative 3, I get negative 10 over 1. So my limit is equal to negative 10. Again, that means that on your graph, there is a hole at negative 3, 10. Alright. So, this next one, limit as x goes to 4 First method is substitution. Square root of 4 is 2, minus 2 is 0 over 0. Alert, alert, keep going. Okay, this case though, to keep going, can you factor this numerator? That square root's going to make things kind of tricky. Can you easily factor this denominator? Some of you might see that in a way that can factor, but not so easily. So instead what we want to do is multiply by the conjugate. You remember from Unit 2, multiplying by a conjugate helps us force a difference of squares so that things with the square roots cancel out. So here, I'm going to multiply the top by the conjugate, square root of x plus 2. If I do that in the numerator, I have to do that in the denominator. Foiling this out, I'm going to get the limit as x goes to 4. Yes, you should write that as you go. Square root of x times the square root of x is just x, plus 2 root x minus 2 root x, those drop out, minus 4, all over, well, I'm just going to leave this as x minus 4, square root of x plus 2. Canceling things out, x minus 4, x minus 4, so now I have the limit as x goes to 4 of 1 over the square root of x plus 2. Trying substitution now, when I plug in 4, I get 1 over the square root of 4, which is 2, plus 2. So my final limit is 1/4. Okay, again, that means that there was a hole at 4, 1/4. Alright, so substitution again. Square root of 0 plus 4 minus 2 all over 0. Well, clearly the denominator is 0, so is the numerator. We must keep going. Can you factor this numerator or this denominator? Hopefully you just said no. So instead, let's multiply by a conjugate. So the conjugate of the numerator, which I'm picking because that's the one that has the root in it. Okay, it's not always the numerator, it's the one that has the root that you're trying to force a difference of squares to get things to cancel. Oh, those should be plus 2's. When you go ahead and FOIL that, we get the limit as x approaches 0. These ones, the square roots are going to drop, and you get x plus 4. Plus 2 of those, minus 2 of those goes away. Negative 2 times 2 is negative 4. Over, I'm going to leave this part undistributed. So in the numerator, those drop out. I get x over x square root of x plus 4. Made my radical too big. Plus 2. Well, now these x's are going to cancel out, and I'm left with 1 over the square root of x plus 4 plus 2. When I plug in my limit, I just got rid of the problem spot right there. So when I plug in 0, I'm going to get 1 over the square root of 0 plus 4 plus 2. It's going to be 1/4. Please note that is total coincidence that it matched this answer up here. It's not always going to be 1/4. But again, substitution is your first method. If substitution fails you, because you get 0 over 0, you have to keep going. Try factoring or multiplying by a conjugate. If substitution leads to the following, where'd it go? A number. Then your answer is just a number. If substitution leads to 0, your answer is 0. If it leads to a number over 0, then you've hit an asymptote, and you are either going to go to plus infinity, minus infinity, or it does not exist. If you get 0 over 0, keep going, just like Dory.